This is going to be 100-3. We're going to take a look at exponential and logarithmic functions, but we're going to focus on converting between these exponential and logarithmic forms and evaluating log expressions. And so that leads us to our objectives, which are converting functions between logarithmic and exponential and evaluating log expressions. Now, the previous lesson, we dealt with exponential functions in the form of y equals a to the x, and we talked about it being 1-to-1 and therefore had an inverse, and we said that that inverse is going to be the log. Now in this process of finding the inverse, we switch the x and y, so x equals a to the y, and then solving for y, we would have to use the following definition: y equals log base a of x if and only if x equals a to the y. Now this is a fancy way for us to say that we can eliminate bases by applying those logs. And so if you notice this pattern here, see this said log base a, I take that a and put it as a base over here. And so that's how it became x equals a to the y. Likewise, I can take that a, put it as a log over here, and so that's why I got the log base a of x. So if I had log base 5 of 125 equals 3, or 125 equals 5 to the third, well, examining these, logarithmic form has logs. Exponential form, exponents. That's how we know the difference between the two. Now notice I take the 5. I move the 5, make it into a base. So I get 125 equals 5 to the third. Or I could say base 5 to both sides. And we talked about how that base and that log cancel out like that. And I can do the same analysis with these. So our first example here says convert each of the following to a logarithmic equation. So our first one, so to turn it into a log, well, I have to get rid of this base, so I can take log base 2 to both sides. Now doing that, this becomes log base 16 equals log base 2 of 2. Those cancel out, and so I get log base 2 of 16 equals x. This is now in logarithmic form. For this next one, this is my base with the exponent, so I can take base or log base 10 to both sides. And so this becomes a log base 10 of 10 to the negative third, and this becomes log base 10 of 0.001. The log base 10 and the 10 cancel out, and so I get negative 3 equals log base 10 of 0.001. Now it's in logarithmic form. For C, dealing with this e that I briefly talked about, remember e and log base e, or natural log, that's what ln or log base e is. So I would have to take log base e or ln to both sides. Those cancel out. And so then I get t equals log base e of 70. Now notice, it says like if I took the e, brought it to the other side, and put a log there. I took the 2, brought it to the other side, put a log there. Now let's practice converting from logarithmic to an exponential equation. So now in this instance, this is log base 2 of 32 equals 5. Well, I can take that 2, make it into exponent, bring it over here, or base 2 to both sides. The 2 and the log base 2 cancel out, and so I get 32 equals 2 to the 5th. This is now in exponential form. Now I know what we're thinking, oh, but I can say 2 to the 5th is 32 equals 3. Don't do that. We want to leave it in this exponential form. For this next one, I can get rid of this log and take base a to both sides, right? Take it, move it over there. So those cancel out, so I get q equals a to the 8th. And then this log, this is t, so if I take the t, move it over there, log base t and the t cancel out, and so I get t to the x equals m. Now there's a reason why I said that we need to convert between these, because typically it's easier for us to solve equations, like logarithmic equations, when they are in the exponential form. Now the reason why it's easier is because it's the way that it's being counted. Counting 2 to the 5th is much easier than counting log base 5, or log base 2, or log base 10. Like counting with 2 to the 5th, or 2 to the 6th, or 2 to the 7th, it's much easier for us to count. So converting between them helps us solve and interpret information. Now, when we're going to go through this process of evaluating, which is going to be our next thing, we want to take a look at this property here. Now this property says that if I have some base to some power equaling the same base to a different power, I can make the assumption that the powers are the same. So if I say a to the b equals a to the c, then the exponent's a equals c. Okay, so bases are the same, set the exponents equal to each other. It's going to help us evaluate logs. Now I'm going to show you this in a second. There's actually two ways for us to evaluate. One of them, understanding the relationship between a log and a base, how they're inverses of each other, I could just say, oh, well, what if I make this into the same base? So I ask myself the question, 216 is 6 to what power? In this case, it's going to be 6 to the third power. The log base 6 and the 6 cancel out, and I get 3. So that's a way for us to do that. Now this trick only works when, or this ability or this process of us solving this, it only works when it's actually like nice numbers. The moment that they become not very nice numbers becomes a little confusing. And so it could help us to convert this into an exponential equation for us to be able to solve this. So I have this log base 6 of 216. Well, I can say that this equals some number x. No idea what that equals. So now converting it into an exponential equation, you could take base 6 to both sides. So you get 216 equals 6 to the x power. Then that assumption, remember I said if the bases are the same, I can set the powers equal to each other. So what if I turn the 216 into 6 to the third power? Now the bases are the same, I can set the powers equal to each other. Now remember, I can't say my final answer is x equals 3 because where did the x come from? There's no x in the original problem here, right? So we just have to make sure we just isolate the fact that the log base 6 of 216 equals 3. Now this could be one of the reasons why this might be a little easier, because once again it's like, how do I manipulate this? Well, I could bring the 8 to the top, and I could say log base 2 of 8 to the negative 1, and then I could say log base 2, well, 8 is 2 to the third power, and that all of that's to the negative 1 power. And so the log base 2 of 2 to the negative 3, because you have to multiply those numbers together, and so those cancel out and you do get negative 3. So that's a way. But then I could also say, well, what if I don't know what it equals, or I don't see where it's going, so I just say it equals some number x. I take base 2 to both sides, so those cancel out, so I get 1 over 8 equals 2 to the x power. So now that I've converted it into an exponential form, now I want to use that property of exponents to be able to solve for this. So I could still bring that 8 to the top. 8 is 2 to the third, which is 2 to the negative 3. And so now I can set the powers equal to each other. And we just remember, we isolate the fact we can't say x equals it. We just know that that statement's now going to equal negative 3, or it simplifies into negative 3. So this is why I said that the shortcut helps us, because now this is a little weird. Especially, yikes, I have this 1/3 there. What's going on with that? It's a little bit ugly. So let's say that it equals some sort of number x. So now, first step, converting it into an exponential form equation. If I take base 1/3 to both sides, that cancels out. So I'm going to get 1 over 243 equals 1/3 to the x. Well, let's bring this up, and let's bring this up. So I get 243 to the negative 1 power equals 3 to the negative 1 all the way to the x. So now I need to think, how can I make 243 into base 3? So 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3, hey, that's 243, so that's 5. So this is going to be 3 to the 5th all the way to the negative 1, and that equals 3 to the negative x. So now the bases are the same, so I can set the exponents equal to each other. So that's negative 5 equals negative x. Divide both sides by negative, I get 5 equals x. And so I can say that this statement is going to be 5. Remember, you cannot say it equals x, because where did the x come from in the beginning? Log base 216 of 6. So once again, equals some number x. Don't know what it equals. It's weird. How do I make a 6 into 216? I don't know what's going on there. So then, take base 216 to both sides. So 6 equals 216 to the x power. Well, this is 6 to the first power. This 216 to the x, well, 216, 6 times 6 times 6. Okay, that's 6 to the third. So I need to make the bases the same using my property of exponents. So 6 to the first equals 6 to the 3x. Now that the bases are the same, set the exponents equal to each other, divide both sides by 3, x equals 1/3. Now remember, we have to say that this just simplifies log base 216 of 6 equals 1/3. By saying x equals 1/3, okay, we're technically inserting information that's not supposed to be there. Now, a few other things. This represents the relationship between bases and logs. Remember, this 2 and this log base 2, those will just straight cancel out. And so I'm just going to be left with 8. Okay, they do represent that inverse property, so we just know that those cancel out. Now this one's a pretty good one to try and be able to figure this one out. Remember, our first instinct is to kind of think, oh man, that negative, what do I do with that negative? Well, remember, a negative means you have to flip it over, the fraction. So this becomes 1 over 117 to the log base 117 of 6. So now this 117 and that log base 117 cancel out, and so now you're left with 1 over 6. So just remember, bases and logs, they represent and have that inverse relationship. All right, so in conclusion, some of the concepts that we discussed today were how to convert between exponential and logarithmic forms when it comes to the equations, and we took a look at evaluating and simplifying log expressions. Now remember, we still haven't gone into how do I simplify a log that has different bases. Like, what about log base 2 of 3? What does that equal? We haven't talked about that yet. We will get there. Now, in your own words, what I want you guys to go ahead and share in the comments is how would I be able to convert a logarithmic equation into an exponential one? And what is the value of converting a logarithmic statement into an exponential equation when evaluating? Now, as usual, if you do have any other questions, please leave them in the comments.